Hello, welcome. My name is Eugene. I am a lecturer in Kenya. I teach professional courses such as SCCA and CPA. My videos cover various topics found in these professional courses. The main subjects covered are management accounting, performance management, and quantitative analysis. I welcome everyone interested in learning something. Sit back, relax, and let's begin. Hello, welcome back to my channel. In this video, I will take you through measures of central tendency. Measures of central tendency provide a single value to summarize a dataset or distribution. These measures represent the center of the distribution and are often referred to as averages. The three main measures of central tendency are the mode, arithmetic mean, and median. Characteristics of a good measure of central tendency. 1. It is easy to understand and calculate. This means that the approach to calculate it is simple and anyone can interpret it correctly. 2. It uses all the values in this dataset so that it can provide a good representation of the data. 3. It gives a single unique value for a given dataset to avoid confusion. 4. It remains stable even when very high or low values are present in the data. The mode is the value with the highest frequency in the dataset or distribution. This means that the mode will appear more than once in the distribution and it will appear the highest number of times in the distribution. For example, a shoe shop can use the mode to determine which size of shoe is highly purchased in the shop, and that can help it to restock as required. Advantages of the mode. 1. It is easy to understand and identify. In small data sets, the mode can easily be identified by observation. 2. It is not affected by extreme values. Very high or low values will not affect the mode. 3. It is applicable to all types of data. For example, it can be used for qualitative data like gender and color. 4. The mode is the most frequent value, hence it can be useful in identifying trends. 5. It is useful in qualitative analysis. It is useful in business and social studies to find the most preferred brand, product, or opinion. Disadvantages of the mode. 1. It may not be unique. A dataset may have no mode or more than one mode, hence making it difficult to interpret. 2. The mode only considers the most frequent value and ignores the other data, which may reduce accuracy. 3. The mode does not use all the values in the dataset, hence it is less useful in further statistical analysis. 4. The mode is less stable since a small change in the data can alter the mode drastically. 5. In some distributions, especially when frequencies are close, the mode may not represent the central tendency of the data well. Example 1. Find the mode of the following data. To find the mode, we write the values from the lowest to the highest, that is from 1 to 12. Then we identify the frequency of each value. After that, we check which value has the highest frequency. The highest frequency is 3, hence the mode is 4. Example 2. The distance from home to school for several students is as follows. In the table, we're given the distance in kilometers in the form of grouped data. Therefore, we have 4 different classes and the number of students in each class. Required, calculate the value of the mode. To calculate the value of the mode, we'll use this formula. We need to identify the model class. The model class has the highest frequency. The highest frequency is 9, therefore the model class is 4 to 6. Using the formula, the mode is 5.33 kilometers. The mean is the average of the values in a given data set. Types of mean: arithmetic mean, weighted arithmetic mean, geometric mean, and harmonic mean. The arithmetic mean is calculated by dividing the sum of all the values by the number of values. For ungrouped data, the formula is sum of x divided by n. For a frequency distribution, the formula is sum of x times frequency divided by sum of frequency. The arithmetic mean can be used to calculate the average price for different products. It can also be used to calculate the average score for students in a given exam. Advantages of the arithmetic mean: 1. It is easy to calculate and understand. The approach and formula is not complicated. 2. It is computed using all the values in the data set. Hence, it is a true representation of the entire data. 3. It is suitable for further statistical analysis, such as calculating the variance and standard deviation. 4. The mean is stable and does not vary much between samples from the same population. 5. The mean is mathematically manipulable. It can be easily used in algebraic and mathematical operations, such as finding combined means or deviations. Disadvantages of the arithmetic mean: 1. It is affected by very high or low values. Very high or low values can distort the mean, making it unrepresentative of the data. 2. The mean is not suitable for qualitative data, such as gender. 3. When class intervals are open-ended, the mean cannot be computed accurately. 4. In highly skewed data, the mean may lie far from the most typical value, giving a distorted impression. 5. Unlike the mode, the mean must be calculated since it cannot be identified by observing the data. Example 3. Calculate the arithmetic mean for the following data. Here we have ungrouped data. We'll use the formula sum of x divided by n. We add all the values and divide by 9 since the number of values is 9. The arithmetic mean is 5.7778. Example 4. The distance from home to school for several students is as follows. We're given the distance in kilometers in grouped form. Therefore, we are given the 4 classes and the number of students in each class. Required, calculate the arithmetic mean. In this case, we have grouped data. To calculate the arithmetic mean, we'll use the formula sum of x times the frequency divided by the sum of the frequency, where x is the midpoint of the class. The number of students gives us the frequency values for each class. To calculate the midpoint of the class, we get the average of the lower class limit and upper class limit of the class. For example, in the first class, 0 to 2, lower class limit is 0, upper class limit is 2. Midpoint, 0 plus 2 divided by 2. We get the midpoint for all the classes. Then we multiply the midpoint x with the frequency f to get x times f. Then we get the total values. We use them to get the arithmetic mean, which is 113 divided by 25, giving us 4.52 kilometers. The weighted arithmetic mean is a variation of the arithmetic mean where some values contribute more to the average than the others. The values that contribute more have higher weights since they are more important. To calculate the weighted arithmetic mean, we'll use the formula sum of x times w divided by sum of w, where w is the weight. For example, the weighted arithmetic mean can be used to calculate the average score for an employee's performance based on different factors, where some factors have higher weights compared to others. Example 5. A student's final course marks is based on 4 categories as shown in the table below. The categories are assignments, quizzes, CAT, exam. We're given the percentage marks for each and the weight in percentage and also in decimal form. Required, calculate the weighted arithmetic mean. To calculate the weighted arithmetic mean, we'll use the formula sum of x times w divided by sum of w. The percentage marks will be x and the weight is w. We multiply each percentage mark with the corresponding weight to get xw. Sum of xw is 83.5%. Total weight is 1. Therefore, when we divide the sum of x times w, 83.5%, by the total weight 1, we'll still get 83.5%. The weighted average mark is 83.5%. The geometric mean is an average that is found by calculating the nth root of the product of n values. The geometric mean for x1, x2, x3, x4 up to xn is computed as follows. The geometric mean for x1, x2, x3, x4 up to xn with frequencies f1, f2, f3, f4 up to fn is computed as follows. The geometric mean can be used to calculate the average population growth rate in a country. Example 6. Calculate the geometric mean for the following data. The number of values is 9, therefore n equals to 9. We multiply the 9 values, then get the 9th root, which will give us a geometric mean of 4.5024. Example 7. The distance from home to school for several students is as follows. We're given the distance in kilometers in group form. We have 4 classes and the number of students in each class is stated. Required, calculate the geometric mean. In this case, we have group data. We'll use the following formula to calculate the geometric mean. From the answer for example 4, the midpoints are 1, 3, 5, and 7. The frequencies for the classes are 4, 5, 9, and 7. Total frequency is 25. Using the formula, the geometric mean is 3.8343 kilometers. The harmonic mean is an average found by getting the reciprocal of the arithmetic mean of the reciprocals of all the values. The harmonic mean for x1, x2, x3, x4 up to xn is computed as follows. The harmonic mean for x1, x2, x3, x4 up to xn with frequencies f1, f2, f3, f4 up to fn is computed as follows. The harmonic mean can be used to calculate the true average speed of the car for an entire journey. Example 8. Calculate the harmonic mean for the following data. Since we have ungroup data, we'll calculate the harmonic mean using the formula n divided by sum of 1 over x. The number of values is 9, therefore n equals to 9. Using the formula, we'll take 9 divided by the sum of the reciprocals for all the values. That gives us the harmonic mean is 3.446. Example 9. The distance from home to school for several students is as follows. We're given the distance in kilometers in group form. We have 4 classes and the number of students in each class has been stated. Required, calculate the harmonic mean. In this case, we have group data. To calculate the harmonic mean, we'll use the formula sum of f divided by sum of f over x. From the answer for example 4, the midpoints for the classes are 1, 3, 5, and 7. The frequencies for the classes are 4, 5, 9, and 7. Total frequency is 25. Using the formula, the harmonic mean is 2.9527 kilometers. The median is the middle value when the values are arranged in ascending order. It divides the data into 2 equal halves. For example, we can determine the median height of the female models working in the fashion industry. Advantages of the median. 1. The median is not affected by extreme values. Very high or low values will not affect the median. 2. The median is simple to calculate and understand, especially for small data sets. 3. The median can be determined even when the class intervals are open-ended. 4. The median can be used when the data is ranked but not measured numerically, for example, satisfaction levels. 5. The median represents the middle position of the data. Disadvantages of the median. 1. The median does not use all the values in the dataset. 2. The median is not suitable for further statistical analysis, such as calculating the variance and standard deviation. 3. The median is only concerned with the position of the values, hence it ignores the actual magnitude of the data. 4. The median is not suitable for qualitative data such as gender. 5. In some datasets, especially with an even number of values, the median may not represent a single distinct value in the dataset. Example 10. Determine the median for the following data. First, we arrange the data in ascending order from the lowest value to the highest value. For ungroup data, we can get the position of the median using a half of n plus 1. The number of values n is 9. Therefore, the position of the median is a half of 9 plus 1, which is 5. This means that the fifth value, counting from the lowest, is the median. In this case, the median is 4. Example 11. The distance from home to school for several students is as follows. We're given the distance in kilometers in group form. We have 4 classes, and the number of students in each class has been stated. Required, determine the median. Since we are dealing with group data, we'll calculate the median using the following formula. For group data, we can get the position of the median using a half of n. N in this case will be the total frequency. The total frequency is 25. Therefore, the position of the median is a half of 25, which is 12.5. The position for the median is 12.5, which we can also refer to as the median frequency. We'll use the 12.5 to determine the median class. To determine the median class, we need the cumulative frequencies. We'll calculate the cumulative frequencies for all the classes. For the first class, the cumulative frequency will be 4, the same as the frequency of the class. For subsequent classes, the cumulative frequency will be the previous cumulative frequency plus the frequency of that class, which will give us 9, 18, and 25. To identify the median class, we use 12.5. We check under the cumulative frequencies, do we have 12.5? Since we don't have exactly 12.5, we check which value is less than 12.5 but close to 12.5, and that is 9. Since 12.5 is higher than 9, we'll take the next class to be the median class, that is the class 4 to 6. Using the formula for the median, we have the lower boundary for the median class, which is 4. Then in brackets, we have the frequency for the median, the position for the median, 12.5. We subtract the cumulative frequency before the median class, which is 9. We divide by the frequency of the median class, 9, times the class width. The class width will be the difference between the upper class limit, 6, and the lower class limit, 4, for the median class. That will give us a median value of 4.7778 kilometers. Thank you for watching up to this point. I hope you enjoyed the video and learned a lot. Please support the channel by subscribing. Remember to like and comment. See you in the next video. Goodbye.